working with variables on both sides and special cases. Here's the big idea. What is the difference between these two solutions? This one results in 2 equals 6. This one results in 4 equals 4. Write that down and we're going to talk about that. All right, so Mario, what is different between these two solutions? This one is no solution. If we take an x off of each side, which is legal, right? That's a balanced move. We can take an x off of each side. But if we do, we get 2 equals 6, and 2 doesn't equal 6. So that's no solution. This one was simplified for you. You've got 4 minus c equals, I've got 2 and another 2, which makes 4. And I have positive v and negative 2v, which makes negative v. So if I take a v off of each side, I get 4 equals 4. 4 will always equal 4. So we call this one infinite solution. Because no matter what v is, let's say v is 10. If we take 4 and subtract 10 off of both sides, aren't we still going to get the same answer? What if I had 4 times 1,000? Wouldn't it both sides be 4,000? So no matter what v is, it will always be infinite solution, always be equal. Questions on that? All right, go ahead and write down your steps, same steps as yesterday, and let's do some more practice. Okay, so let's begin. Pencils down. So I'm going to go ahead and solve this one for you. So our first step was to distribute. Let's just uncover our steps here. I don't have anything to distribute. I don't have any parentheses. So next, clear fractions. No fractions to clear. Combine like terms. I've got a 6r and a negative 6r. Doesn't 6r and negative 6r, aren't those a zero pair? So I'm left with negative 5 equals negative 5 minus 3r. If I have a negative 5 on both sides, can't I just remove both of them? Or I could just add 5 to both sides. That removes them as well. Now I'm left with what's over here? Nothing. What do you usually write for nothing? 0 equals negative 3r. I have to get r by itself, so I'm going to do the inverse. The inverse of multiplying is dividing. 0 divided by negative 3 is just 0. These cancel and I get r equals 0. This is a solution. Oftentimes when we do special cases, a lot of kids will say, oh, I got 0, so there must be no solution. It's not no solution. There is such a thing as r being equal to 0. Okay? Go ahead and write this one down in your notes. Okay, let's move on. Pencils down again. This time I've got negative a minus 4 minus 6 equals negative 10 minus a. I can't distribute. There aren't any fractions to clear. Oh, I'm going to combine like terms. Let's change our color this time. I've got a negative 4 and a negative 6. Gives me negative 10. I also have a negative a. On this side I have negative 10 and also a negative a. Don't I have the same thing on both sides? The exact same thing? They're just in a different order. I could reorder them. It's commutative property, right? I could add a to both sides. I could take a off of both sides. I could take 10 off of both sides. Still going to be equal, right? So ultimately, This is infinite solutions. Go ahead and write this down. Any questions on that? Pretty self-explanatory, right? All right, so let's move on to the last one. Pencils down. Distribute. Okay, I do have something to distribute this time, so I'm going to distribute. I've got 6n minus 50 equals 8, negative 2 times 1, and distribute negative 2 to negative 3n. 6n minus 50 equals 8 minus 2 plus 6n. So I distributed, no fractions to clear. Let's go ahead and combine like terms. Let's see. I don't have anything to combine over here. Over here I have an 8 and a negative 2. So let's rewrite this side. 6n minus 50 equals 6 plus 6n. If I have the same thing on both sides, can't I remove the same thing off of both sides? Right? Same thing as saying negative 6n to both sides, correct? It's going to give us the same result. That goes away, and that goes away. And I'm left with negative 50 equals 6, and that is not true, so this is no solution. Go ahead and write this one down. Questions on this? All right, so let's move on to trying this one. So one person gets the whiteboard, one person needs to use the clicker. So let's start with A's. A's, what do you want to do? Clicker? Okay, so A's, you get the clickers, B's, you get the whiteboard. Do this one for me and put it in your clicker. I'm going to start the clickers right now. Okay, clickers are started. Okay, so back on me, 5, 4, 3, 2, 1. Most of you have your answers in. Let's see how you guys did. Most of you chose B. That's good. And the answer is B. Okay, so I'm going to go ahead and distribute. So I have negative 8 times 2n. Negative 8 times 7 equals negative 4 times n, and negative 4 times 8 gives me negative 16n minus 56 equals negative 4n minus 32. I don't know why that couldn't come to me for a second there. Can you see everything okay? Okay, so which one's bigger, 4 negative n's or 16 negative n's? 4 is bigger, right? So I need my variables on this side and my constants on this side. So I'm going to go ahead and move that 16 by adding 16 n's to both sides. And I'm going to move that 32 by adding 32 to both sides. When I do that, I get negative 24 equals, what's 16n minus 4n? 12n, right? Let's make this bigger. Finally, if I divide 12 to both sides, I get n equals negative 2. Questions? Yes.
We have a 4 to both sides instead of an answer. Instead of 16.
Mm-hmm. Yep. You know why? Because you still used a balance move. You added 4 to both sides, and you got negative 12 and positive 24 on the other side. Exactly. Good job. All right. Try this one. Now I want A's to write and B's to talk. Good job. I'm going to start your clicker. Okay, so I hear arguing. I hear clearing the denominator. I hear lots of good things from you guys. This one was a little bit more challenging. All right, 5, 4, 3, 2, 1. I appreciate the discussion. Let's come back together now. Let's see, I've got 9 answers in. Means 18 of you. That's pretty good. Pretty good. I've got that many of you on the same page. I'm not going to ask again. I'll wait. Perfect. Let me cover this up and let me take care of this one for you. So, I don't have anything to distribute. Now I need a clear fraction. What is my LCM? 10. So I need to multiply everybody by 10. Okay? I'm just going to do, if it makes it easier for you, instead of doing a whole bunch of parentheses, can't I just do a little parenthesis right here and put 2 times 5? Don't I have to give this to everybody? 2 times 5. 2 times 5. 2 times 5. That is a balanced move. I multiplied every single thing up here by 2 times 5. Brenda, you ready?
Yeah.
2's cancel. Nothing cancels here. 5's cancel. 2's cancel. 5's cancel. I'm left with 5 times 5 is 25. Can't forget that negative. Negative 25. Negative 2r times nothing canceled, so it's just negative 2r times 10, which is negative 20r, equals 8 times 2 is 16, plus an r right there, right? So 16r. I've got a negative right here. Negative 5 times 5 is negative 25. And negative 18 times 2r is negative 36r. Let's take a vote. How many of you like it this way where I just put the multiples on top and we cancel?
Yeah. Could you have done rid of my little features?
I could have. Very good. Yes, I could have. That would have made it easier. How many of you would rather I multiply everything out and have parentheses around everything? A couple? I could have. That's even better. I had some people combine like terms before they even started. They saw that, guys, listen up, because this is important. Some people saw that you could remove 5 halves off of both sides before you even start. Wouldn't that be a legal move? Balance move. I could take 5r off both sides. Some other people thought that 8 over 5r and negative 18 over 5r are also like terms. You could have simplified those too before you decided to multiply everything by 10. All right, so negative 25, negative 20r, I've got 16r and negative 36r. Okay, Brenda, so that is your official warning. Negative 25 minus 20r equals, I've got 16r and negative 36r makes how many r's? Negative 20 r's minus 25. At this point, you should see that you could easily take off 25 from both sides. You could also take off 20r from both sides, or you could just leave it like that because they are both the same. This is infinite solution. or all real numbers? Let's write it like that. Let's write it like all real numbers. You know how there's an easier way to write it. It's a big R. Means all numbers are in that solution. Why does that have 2 lines? Because that's just a fancy way of writing this big R. It means all real numbers. No matter what in math, if you see a big R like that with 2 lines, it means all real numbers. So why don't you guys, do we really need to copy this one down into our notes?
No.
Okay, I'd rather you get more practice. So here's another one. Wait, I had a question. Yes?
What's the difference between the big R and the
They're the same thing. Infinite solutions and all real numbers are the same thing. All right, you guys, do this one. This time, who was last? A's, so we'll go to B's. All right, 5, 4, 3, 2, 1. Let's see how we did. Out of those that turned in answer, you guys did pretty well. Most of you are answering C. We're going to do it together. I need the talking to stop. I will wait. Perfect. Okay, so I don't need to distribute anything. Can I combine anything?
Yeah.
What can I combine? But they have fractions. Let's just leave that alone for a second. Let's clear the fractions. So what can I multiply everybody by? So I'm going to multiply 2 times A, and 2 times 3/2, and 2 times 1/2 A, and 2 times 1, and 2 times 2A. Everybody good with that? All right, so this 2 goes away, this 2 goes away, and we're left with 2A plus 3 plus A equals 2 plus 4A. I've got 2A and 1A makes 3A. I have a positive 3, and I have 2 plus 4A. 4A's is larger than 3A's, so I'm going to subtract 3A from both sides. And I'm going to subtract 2 from both sides so that I can get my constants on this side. I'm left with 1 equals A, and that's my answer. Any questions on this one?
It's okay if you do it differently.
Yes, absolutely. There's lots of different ways to approach these problems.
At first, I just took away the A.
Both sides? Good. Good. All right, so I'm going to skip over these because we're running out of time. What did you learn today? Raise your hand. Somebody tell me what... No, I do not want you shuffling. This is not a time to put your things away. I will wait until everybody stops moving. What did we learn today? Jesse. What did we learn today?
We learned about putting variables on both sides.
Okay, we've had variables on both sides. What else? We added to that. Yes. Andrew. We learned about no solution. What else? All real numbers. Excellent. Why do we say that some equations or inequalities are special cases? I am not going to continue. I will keep you for lunch. Why do we say that some equations or inequalities are special cases?
They have no solution.
Because sometimes things have no solution, right? The person next to you is absent. How would you explain? I will wait. Stop moving. Kaja, why do you get to move and nobody else gets to move? Is that still moving? Okay. On your assignment sheet, I want you to write down, I know an equation or inequality has no solution when, and I know an equation has infinite solutions when. When you're finished writing that down, you may go.